In this set of videos, we're looking at the Chinese Postman problem, 610 in your syllabus. So the Chinese Postman problem is a relatively recent problem in graph theory. It was developed in 1962, and the idea is that we're trying to find the most efficient route for a postman. So of course a postman has to visit every mailbox, which means he has to walk on every street. And so in a graph theory, that's like talking about we must have a walk that includes every edge. So and we want to minimize the weight. So for the postman, we want it to be the shortest walk possible. So if all the vertices are even, then that means we can just make an Eulerian graph. So that's what we look for, is the Eulerian circuit. So all vertices are even, then just find the Eulerian circuit. But if you have odd vertices, then your odd vertices have to have there must be an even number of odd vertices. And that means we're going to end up with a multi-graph. There's some streets that the postman would have to walk down repeatedly. So if odd vertices, the first thing you want to do is list all possible combinations of pairs. So find all pairings. And with all those pairings, you want to find the connections with minimum weight. And then amongst those, you want to take enough pairs such that you cover all the odd vertices. So take from the minimums, the least weighted pairings to cover all odds. And those are going to become your multi-edges. So these are the multi-edges. So somehow, between all the edges of the graph and these multi-edges, you're going to be able to walk the entire path such that each edge is covered, and then the postman delivers all of his mail. So we would add up all the existing edges, add on the multi-edges, that's going to be our total weight. So find total weight and the path. And we're going to look at an example of this in the next video.